Hello and welcome to another installment in the Learn to Pi series. Today we're going to be looking at inheritance and more. We'll be looking over inheritance, overriding, types of inheritance, super method, class method decorator, property decorators, operator overloading, dunder / magic methods. So what is inheritance? Inheritance is essentially when we have a parent class that we create and we want another class that we create to have the same methods and properties as it does. We can then modify this class as we choose, including but not limited to changing those behaviors that we created in the original class and all the properties, and even creating new ones or sometimes removing some features. So there's a lot to do here. Let's look at an example of how inheritance works in Python. First of all, let's create a class. We'll call it food. Then what we want to do is we want to pass because we won't do anything yet. And then we're going to create another class called apple, which using parentheses, we can create as a child class of food. This means that we're inheriting everything inside of food and we're implicitly putting it inside apple without having to explicitly type those things out ourselves. Now let's say we want to do something a little bit more interesting. So what we're going to do is we're going to go inside of food and we're going to create a method and we're going to call it name. Inside of name, we're going to print the name of the item, which in this case is food, and we're not going to do anything inside of apple. So what we've done so far is we've just added a method to food, and apple is the same as it was prior. So nothing interesting going on there. Now let's create two variables, two objects. What we're going to do is we're going to take food and we're going to create one of those, and then we're going to take the apple and create one of those as well. Now, let's see what the name of food is, our food object that we created, f. It should print food. Now, let's say I wanted to see the name of the a object that I created. I did not ever, as you can see, we have not created a method inside of apple called food. But what I can do, because apple inherits from food, is I can use that method inside of apple. So let's run it and see what happens. And we get food. Now let's say we want to change this behavior inside of apple. Using the same example, let's then go into apple. Let's create the method name. And since we're creating a new method inside with the same name, what we're doing is overriding this method. That means that we're still taking it from the food class, the parent class, but we're changing the way that it works. So if you were to call this method from the food class or from the food object that you create of that class, then it'll act differently when we override it in the child class than it would have previously. So let's see what this looks like in action. Basically, we're going to change the behavior of apple to not print food, but to print apple, because that is the name of the food. So let's once again check what happens if we print the name of the food. It still prints out food. Now let's print out the name of our apple object that we created and see if it differs in any way. And don't forget to put self inside. And as you can see, it has printed apple, which is different to what we did prior. Now we'll be looking at the three different types of inheritance: single, multiple, and multi-level. Single inheritance is an example of the inheritance that we've been looking at so far. It's when we have a parent class and the child class takes all of those methods and all of those properties inside of the parent class and it uses them itself. So let's create a class here. Let's call it school. And let's pass. And now let's create another class and we'll call it room. And we'll say that each school has a room inside of it. And so this inherits from school. And once again, we'll pass. And so what we've created here is a parent-child relationship. We've created a classroom that inherits all of its features from school. Within single inheritance, we can not only override different methods and properties, but we can also add things to the class. So for example, if we wanted to track the number of students, we can add a property within room that is not within the school to track that. Let's say that's equal to 5. Now, what happens when we create a school? Let's call it S. And let's see how many students are in the school. We actually get an error because school is the parent class of room, which means that everything inside school gets placed inside of room, but it does not work in the opposite direction, which means that if we create something in the child class, it doesn't necessarily make its way back to the parent class. But let's say if we created a room, and now if we try to get the number of students, it prints 5. So we can also add things to classes from the parent class to the child class. We can add things in the child class that were not in the parent class as well. Not only overriding, but also adding things. Multiple inheritance is a type of inheritance in which the child class inherits from 2 or more classes, which means that it can have properties and methods from not just one class, but a second one too, or even a third or more. So let's say we want to see what this looks like in action. What we can do is we can create a code block here. Let's create a class called chicken. And inside of this class, we'll have a method called lay egg. And we're going to print egg has been laid, or laid. Now, we're going to create a second class called duck. And inside of this class, we're going to put another method called quack. And we're going to print quack. And finally, we're going to create another class called turkey. And inside of this class, we're going to create a method called spread tail. Inside of this method, we're going to print tail has been spread. Now, what we can actually do is we can create another class called duckin, and it's going to inherit from chicken, duck, and turkey, all inside parentheses. And so now all of these methods that we have in each of these different classes have been passed onto this class over here, this child class called duckin. So what we can do is we can create a property, for example, called name, and it's going to be duckin. So it's a sort of mixture of the three, and we're not going to change anything else about it. Now what we can do is we can create a duckin, and we can use the methods that are in all the parent classes without any issue. So we can use all of these methods, and we can also check its name. So everything that was in all of these previous classes, these parent classes, has been passed onto this class, this child class. And we've also added a new property to this class that isn't in any of the previous classes. And so let's see what happens when we run this. So as you can see, all of these work, and then we also get the additional variable that we added, the property. So what we can also do in here is we can even override one of the previous methods. So let's recreate quack. Maybe it quacks in a different way than a duck would, for example. Maybe it says quonk, for example. And we're going to print quonk. And now, this time, let's run it one more time and see what happens. So as you can see, everything functions the same way except for the method that we changed. Instead of saying quack this time, it said quonk. So that's how multiple inheritance works. Pretty cool. Finally, we have multi-level inheritance. What happens in multi-level inheritance is that you have a class A, for example, which inherits from a class B, which inherits from a class C, and so on. Essentially, you're creating more than two layers. You have a class which inherits from another class, which inherits from another class. And what ends up happening is that the first class, which has the first layer, the top layer, which has all of those methods and properties, well, those get passed down to the child class, which can add or override those. And then that also gets passed down to the final child, for example. And in this case, we would have the base class, which is the one at the top layer that I was describing. We have the intermediary class or classes. There may be more in the middle. It's sort of like a sandwich if you think about it. And finally, at the end of the sandwich, we have the derived class, the bottom bun if you think about it in that way. And that is in what inherits from all the previous classes. But if there are any changes made along the way, then it will not inherit the original versions of those properties or methods, but it will instead inherit those changes. So keep that in mind. Let's see what that looks like in practice. We can create a class called grandfather. Inside that class, we're going to pass. Then we can create another class called father, which inherits from grandfather. And we're going to pass. Finally, we're going to create a class called child, which inherits from father. Then we're going to pass once again. Now everything that was inside grandfather gets put into father, which can then be remixed, changed, added to, or some other thing done to it. And then that gets passed down to child, which can then do whatever it wishes with that information or that data. Now what I've done here is I've given each of these people a name. Let's say we want to create a method in the grandfather class. We're going to call it name or say name. And what the grandfather returns, he's very straightforward. He just returns his name. Let's print that. Now, the father, he has a different way of doing things. Throughout his life, he's realized that it's a bit too difficult to say Patrick. So what he does is instead, he says Pat. And now the child is very young. So what he says, when he tries to say his name, is goo goo ga ga, because he's a baby, let's say. Now, what we can do is we can create a grandfather, we can create a father, and we can create a son or a child. And let's say we want each of these to say their names. So say name. Then we'll go on to the father. And then let's go on to the child. And let's see what happens. So as you can see, they all have different things inside of them, even though they inherit from each other. Now let's say that the grandfather has something universal. Let's say he has a family heirloom. And let's say it's a hairpin, or perhaps it's a ball. If now I wanted to access, for example, the father's family heirloom, it would be the exact same as the grandfather's. And it would be the same if I did it with the child. He would still inherit what was in the father's class, and he would inherit from what was in the grandfather's class. So as you can see, things are passed down, so to speak, through the generations. let's talk about the super method. What the super method allows us to do is it allows us to access information from the parent class of the current class, or in our case, the child class. To make this look simple, I've created a class literally called parent, and then a child class literally called child, which inherits from its parent. Now, if we try to print the age of the child, first of all, let's create a child here, and let's print its age. You can see that we get the actual age of the child. Now let's say for some reason we can't create a parent class, but we still want to access the information inside it. What are we to do? What we can do is we create a method here called parent age. And we can create super age. And now, what happens when we get c.parent age? Oh, and we've got to return that, of course. Now we get 32, which is the parent's age. Very cool. Now let's say we want to change something inside of the class, like a method or property, during the runtime of the program, without changing the code beforehand. To do this, we use a class method decorator. To demonstrate this, I've created a scenario. First, I'm creating a class person, and within it, I'm creating a property age, which is set to 25 by default. Then I'm creating a method called changeAge, which allows us to change the age of the object. Next, I'm creating an object called Jerry, and then I'm printing Jerry's age. I'm going to try to change the age of Jerry using the changeAge method that I created. Then I'm going to print Jerry's age, and finally, we're going to compare it against the person class's age. Let's see what happens. As you can see, it starts out as 25. When we print Jerry's age, we also get 25 because we didn't change his age. Then when we use the changeAge method, Jerry's age changes to 20. And if we compare it against the class, it has remained the same. Now let's try using the class method decorator. What this is going to do, and it's going to tell the class that if we create an object and we use this function, we don't want to change the value of the property in the object. We want to change the value of the property in the class. Now let's see how our values change. Remember, we currently have 25, 20, and then 25 again. So we made Jerry younger, basically. Let's see what happens now. So what we tried to do is we created a person, Jerry. Let's see what his age is from the beginning. It's 25. Then we're going to change Jerry's age, and we're going to print Jerry's age. And as you can see, we get 20. Finally, we're going to print the person class's age, and we get 20 as well. So not only did Jerry's age change, but the age of the class also changed. In programming, when we want to control the type of data that another programmer has access to in our classes, or even that we have access to in our classes, we use get and set methods. These allow us to access variables without changing them, or change variables without accessing them necessarily. This is useful when we want to limit the control that people have to our objects or classes in programming, and we can see how to do that here in Python with getters and setters. To see how that works, we start by creating a class. Let's call it goat. This goat is going to have an age. We're going to create a method now with the decorator property. This is what allows us to define this as a get method. Let's say we want to access the current age of the goat. So we're going to create a method for that, and we're going to return age, or the age of the goat. Now, let's create a goat. And now let's print its age. There we go. And we get its current age. Now let's see what happens when we try to change this age to something a little bit different. Like, let's say we wanted to make this an 18-year-old goat so it could access certain sites on the internet that it should not be able to access. As you can see, we get an error because we're not allowed to do that. This is specifically for getting information, not for setting it or changing it. So that's what we're doing by using this over here. To demonstrate how setter works, I've created a class called dialog. Inside this class, I've created a property called Derek. I've then created a accused name get method and a accused name set method. And the way that you create one of these is by using the decorator with the name of the property dot setter added to the end of it. And you have to make sure that this is the same as the property decorator created before, the get decorator. Now I've created a method in here called accuse, and what this will do is it'll print this value here, this property, and some other text. So let's see how this works. I've created here D for dialog, a little object, and I'm gonna use the accuse method, see what happens. As you can see, it prints Derek is responsible, because that's the default value for the property that we created here. Let's say I want to change this property without accessing d.accused. I want to use specifically accused name. So let's say the accused name is going to be Elizabeth. And now what we should see is that without ever calling accused or ever using d.accused, we will actually be able to change the variable using this setter over here. So Derek is responsible should change to Elizabeth is responsible. Let's see what happens. As you can see, that's exactly what changed. Let's say we create an object or a class in which we want to use the operators such as plus, minus, modulus, any of the above, and lots of more. Well, to allow us to change the behavior of the class to apply these operators between different objects that we create, we can use operator overloading. To show how this works, we're going to create a class. We're going to call it number. Inside, we're going to create a constructor. And we're going to take in a variable called num, and we're going to assign that to itself. And then we're going to create another method, and that's going to be add. And this is where the magic happens. So we're going to take self and then another num2. But this is not going to be a number, this is going to be an object, actually. This is going to be the second object that we're adding. So what we're going to do is, let's say we want to print something, just to change the behavior up a little bit. Let's make an f string, let's say adding, and then we'll show, this number as well. And then we're going to return the sum of both our numbers, so self.num and num2.num. Remember that num2 is not, in fact, the second number itself, like an integer, it is the second object, so we need to access num within that. Now, let's say we create two numbers, a and b. Let's say that a is 7 and b is equal to 42. Using our class here, so we created two objects. And now let's store the sum by adding a and b. And let's print that and see what happens. So, before we run this code, what we should expect is that because we're using this method here, it's going to actually print that we're adding these two numbers. And then, once we get it returned, we're then going to print that here. We're going to display that. So what we should get is adding 7 and 42, and then we should see the result of that. So let's see what happens. Oh, and here we go. Of course, we need to return the sum. So let's see what happens here. As you can see, 49, we get the sum. So remember not to accidentally create one of these. You need to actually have the sum there. Although this is what happens when you use the add operator, it doesn't necessarily need to be the sum. For example, we could use minus here just as easily, and we would get something completely different. We could even use the multiplication operator. This is just what happens when we use this operator in between these two objects here. It doesn't need to be adding, but we will probably make it that way specifically for this example. So there you see 49. Awesome. Okay, so let's look at some other magic methods, starting with str. What str does is it allows us to create a string representation of an object. So let's say we have a class let's call it person. Let's create a constructor really quickly. Let's pass in self, and let's give him a name, and let's give him, yeah, seems fair. Let's make sure we do that properly. Then we'll say that the name is equal to whatever we pass in that. And now let's create an str. Let's pass in self. And what we should do is return self.name. Now let's create a person. Let's call him Ben. And let's see what happens when we try to print the object. So what happens when we try to print an object is we get this str method here. This basically returns a string representation of the object for us to see. So hopefully what we should see, the result is that it prints Ben. Oh, that's what we get. Perfect. The next magic method is len. And what this does is it basically returns the length representation of an object, if you can call it that. So let's say we wanted to use the method or the function length or len on our object. What would it return? Well, that's what we're going to define now. So let's create that. Here, let's pass in self. And in this version of person, I've initialized it with height instead of name. So we're going to return self.height. There we go. Now let's create a person, and let's say that this person is 170 centimeters tall. And so now we're going to get the length of this person. It should return the length in some way. Let's say the person is lying down, so we're measuring their length, and let's see what we get. Oh, we get their height. The final magic method is the rep_r method. What this allows us to do is give a string representation of all of the arguments necessary to create a clone of our object using the constructor. So let's say here I have a class person with a name and a surname. I have a string representation so we can check what it looks like. And then I have a rep_r function that returns a comma separated list, comma and space separated list of our different arguments here. So let's print what George looks like. His name is George Baker. Let's create a perfect clone of George by creating someone called B. We'll use the person class. And inside, we're going to use the rep_r method with our object with George inside. We're going to split it using comma and a space, and then we're going to unpack that using an asterisk. It's a little bit complicated, but then what we get when we print B is this. Make sure to put that in the right place, and hopefully we should get my name is George Baker twice. There you go, and that's how you use the rep_r method. And that's the end of the Learn to Py series. I really hope you guys enjoyed this. This was a labor of love. It took us lots of time and effort to set this up for you guys. I really hope that you enjoy it and that you learned a lot from it. As usual, we have lots of other socials. We have a GitHub with all of the code that we did in this episode and all the episodes prior available in the description, as well as the website and all of our socials. If you enjoyed this video and series, make sure to like and subscribe and hit that bell icon if you want to see more like this. And stay tuned, because we're going to be coming out with our NumPy series, as well as a number of other series related to programming and computer science and data science and all those things. So if you're interested, again, make sure to hit that bell icon, subscribe, like, share with a friend if you want to give them the gift of programming and data science and learning. And hopefully I'll see you in the next series. So, bye-bye.